You know what I like in video games? Beautiful looking art assets. World art assets. Exploring interesting worlds in video games is a lot of fun. Creating these worlds though isn't, at least not for me. So instead of creating a world, I created an algorithm that creates worlds. In my game Lost Oppai, the whole world is procedurally generated. Every tree, every bush, and every tile is placed by my world generation. Let me show you how I got to this point. I started off, like anyone in procedural generation, with a noise map. I played with some basic Polar noise to generate simple islands by using the noise value as a height threshold to determine whether to place grass or water. This is nothing fancy. It gets much more interesting as soon as we introduce a tile set. You can see that this looks horrible. We need to place the correct tiles on the transitions from water to grass. To do this, I implemented a bit mask to mask each possible tile combination to one of the tiles in the tile set. This looks a lot better. Note that I use a 3x3 bit mask here. This means that we get the 8 neighbors around our tile to determine what tile to place. While this implementation is easy, it does come with a cost, as we will soon find out. With a basic map implemented, I decided it was time to actually put a player into the game. This introduced new issues, such as the player being able to casually walk on water. So the next step was to add collision boxes to the edges of the islands. To do this, we can just check if a tile is water and has grass as neighboring tiles. If that is the case, then place a box collider. One thing that I really would have liked to do is to increase the size of the islands. I think they look pretty nice and interesting, but extremely unrealistic on their current scale. The problem with increasing the size though is that the player will rarely see any water, and if he does, then it will pretty much be a straight line. I think this could work in much bigger games, for example open world RPGs, but this game was never meant to be that huge. Regardless, the islands look decent and the collisions work nicely. Time for... Now we're getting into the spicy part of this world generation. Since I started this project, I plan to implement paths in some way. They're very essential to the game I want to create, so getting them right was important. That said, generating paths is much more involved than anticipated. Up until this point I was able to lazy evaluate my whole world generation. This just means that I don't have to compute anything until I actually needed it. However, this changed with the addition of paths. While there are different ways to generate paths, they all work fundamentally different to generating terrain. I'm using Bezier curves to generate the paths. I have a start point and an end point, and create the Bezier curve that connects these two using random control points. This part is still very simple. The tricky part is that we need to make sure that the two paths are actually on the same island. While you could use something like A-star or other pathfinding algorithms, I just opted to enforce that there is a path by overriding the water tiles around the path. This does tend to create a rather unnatural look, so I experimented a bit with varying width and... yeah, I know, no need to tell me how this looks. Anyways, so after that was figured out, I realized something really nasty. The tile set I worked with didn't offer enough tiles to cover all possible combinations of the 3x3 bit mask. The thing is that we have 2 to the power of 8 possible tile combinations. This means that we need 256 different tiles to cover all combinations. 256! The tile set I use has 16. I briefly considered adding the missing pieces and even started making them myself until I remembered that I absolutely suck at pixel art and realized it would take forever. So this is it? We can't implement paths? No! I remembered watching a devlog by someone who used a weird system where he only needed a 2x2 bit mask. After searching for the video and finally finding it, I came across this talk. This fella talks about the dual grid system, a way to cover a complete tile set with only 2 to the power of 4 tiles. That means we need exactly 16 tiles. Perfect. Now, of course, this does come at a cost, as there are no solutions, only trade-offs. The main problem with the dual grid system is that we use 2 grids to generate the map. One is the underlying tile type grid, and the other is the rendering grid. This means that we cannot just check the center tile to be water in order to place collision boxes, as there is no center tile any longer. So I had to rewrite the collision boxes. I took this opportunity to improve on them and use triangles instead of quads, making the collisions more smoothly. But now that the 2x2 bit mask was working, we have a nice path generation. I really like how the Bezier curves gives the path an interesting little touch. With all of this, the next step was to create points and connect these with the paths. I didn't want to just generate random points, as this could result in points being too close together or too far away. So the way I generate the points is through an algorithm called Poisson disk sampling. It allows me to specify a minimum distance between all paths and generate them as compactly as possible, all while maintaining a decent runtime, although I really only need to run this at the start of the game. Once I generated the points, I needed to figure out how to connect them. After all, I'm interested in the paths, not the points. To do this, I take the points and treat them like vertices in a graph, and use Kruskal's algorithm to calculate a minimum spanning tree. This gives us edges in a way that looks decent and makes sure all vertices are connected together. One thing that doesn't work any longer is the placement of the keyboard hints. Previously, I only had a single path connected to the player's spawn position, so I could just spawn the hints opposite to that. But now we have multiple edges connected to the spawn vertex. This means that I need to figure out where to place the keyboard hints such that it won't overlap with any of the paths. I solve this by first representing each path connected to the spawn vertex as a vector that points away from the origin. Then converting these to polar coordinates and discarding the radius and sort the angles in descending order. Next we just need to iterate over each angle and get the biggest difference in angles. Finally, we just take the result of that and divide it by 2 and we have our new position. I'm sure there already exists an algorithm like this, but it's pretty fun to just reinvent the wheel from time to time. It's also quite useful to be able to derive stuff like this on your own. And it's also much more common in game development than you might think. This completes the main bulk of the world generation. However, I was kinda getting tired of this plain looking map, so I decided it was time to add some. I wanted to add some trees and bushes next. To do this, I calculate the positions of the trees and bushes using the Poisson disk sampling I used for the path vertices. However, I had to extend this to work with varying radii, as I wanted to have the trees be further apart from other trees while allowing bushes to be closer together. This proved to be quite the challenge, and ultimately I only got it somewhat working. It still goes wonky from time to time. It does work good enough though, and with this the game looks already a lot more interesting. You might have noticed some issues with the tree shadows. This is because my mouse didn't even work properly. However, I never realized it because up until this point it never really was an issue. Mind you, I used this exact wizard for 2 other games already. Yeah. So after some bug fixing and one band-aid solution after the next, it worked. I also added some flower patches similarly to how I generate the bodies of water. With most of the world generation done, I decided to reward myself by implementing birds, which I thought would only take about 2 hours to complete, but ended up taking 2 weeks. Finally, the last change I made to the world generation was about the paths. I didn't like how the minimum spanning tree forced the player to backtrack when going to the outer vertices. This happens because Kruskal's algorithm guarantees you a loop-free graph. However, in this case I wanted to have loops around the end. So I extended the algorithm to add loops at the outer vertices, which makes playing the game a much better experience. This is another good example where knowing your shit can really help you in game development. Knowing linear algebra, calculus and computer science isn't required to make games, but it sure is useful. It's also extremely rewarding to be able to solve these things on your own. And this marks the end of my world generation in Lost Oppai. The game is still not finished, as I need to write the dialogues for the NPCs, but all the systems are pretty much done. Getting the dialogue system to work was also much more complicated than anticipated, but that's perhaps for a different video. Until then, take care.